Hi all, welcome to today's class. In this session, we are going to see refraction of light. When you drop a pencil into water, you feel like the pencil is broken at this point. Why does this happen? Let's see. We know that light always travels in a straight line. Then why does this happen? Let's see. The real point lies here. Light always travels in a straight line in a single medium. Light has same speed in a particular medium, but when the medium changes, the speed also changes. So we feel like the light is bending. So light travels in a straight line only in the same medium. When the medium changes, light bends. This is called refraction of light. Now let's analyze what happened here. When we look at the pencil, the top portion of the pencil, between our eye and the pencil, there is only one medium, that is air. Now, come to the second part of the pencil, which is inside the water. When we look at this part, between our eye and the pencil, there are two mediums. First is the air, and second is the water present here. So, as I told you just now, when the light strikes on the pencil and comes back to our eye, from the top portion of the pencil, only air is present. So, it just travels through one single medium. Now, coming to the second part of the pencil, that is inside the water, when the light hits the pencil and comes back to our eye, the light travels through two different mediums, that is air and water. The speed of the light will be different in both the mediums and we feel like the light is bending. Let's go little deeper into it and study this phenomenon. Now look at this line. Here the first medium is air and the second medium is water. Now the light is coming from the first medium, that is air, and it is supposed to go straight like this, but it is bending from here. Here we have some important rays. First is incident ray. Next one is the refracted ray. Here we have an angle, that is angle of incidence. Here we have another angle, that is angle of refraction. As usual, we'll keep a normal here at the point of incidence. We are already aware of optically denser and rarer mediums. Here, air is optically rarer medium and water is optically denser medium. It will be a little confusing, but we'll try to make it simple. You think of air as the crowd present here in the first picture, and you think of water as the crowd present here. Okay. Now imagine that the normal is a father here, and the ray of light is the child here, the sun. Now both the father and the son, they are going to two different areas. First, they are going to an area like this, which is less crowded. That is similar to our air here. When they travel through a less crowded area, the child is free to move. The child will move here and there. The child will move away from father. And father is also not worried because he'll be able to see the child. Now, coming to the second picture, when child and the father goes through this area, it's too much crowded and it will be difficult for the father to see the child. So, they will always stay together like this. The child won't move away from father, but instead, child will move closer to the father. As I told you, just imagine the normal as the father and the ray of light as the child. When they are in optically rarer medium like air, or when they are in a less crowded area, the child will be moving away from the father. Now, when they come to an optically denser medium like water, or when they are in a crowded region like this, the child will be scared, even the father will be scared of losing the child, and both of them will move together. Or the ray of light or the child will come closer to the father. Just think of it like this. So, when an incident ray comes and hits an optically denser medium, it will go near to the normal. Suppose the opposite happens. The ray of light comes through an optically denser medium, it will be already near to the normal, and when it comes towards an optically rarer medium, instead of moving in a line like this, it will move away from the normal. That's it. So, in general, when we look at the story, when the father and the child are in a less crowded region like this, both of them will move away, or the child will move away from the father. Now, suppose if they are moving through a highly crowded region like this, the child will move near to the father or holding the hand of the father, or the child will move towards the father. Think of it like that. Now, when the child is a ray of light and the father is a normal, same thing happens. Normal will be there itself. Normal cannot move anywhere. So, a ray of light, when it comes through an optically rarer medium, it will be away from the normal. When it comes to an optically denser medium, it will go near to the normal rather than moving away from the normal. That's it. So now, suppose if the ray is coming out of the water, it is supposed to go like this, but now it's free to move. So again, it will move away from the water. Remember one thing, in both the cases, this ray, the incident ray and the emergent ray, both will be parallel. The incident ray and the emergent ray that comes out will be parallel. So remember this point in the case of glass slab. To make it more clear, let's take the case of a trolley. Here, trolley is kept in a concrete area. You can see the top view of trolley here, and that trolley is entering to an area with lot of grass. So, when the trolley is coming to the grass, actually it is supposed to move in a straight line like this and enter the grass. But here, the trolley has two tires in front. First tire is here and the second tire is here. So first tire, when it comes in a slanting position like this, only one tire will touch the grass. The other tire will be on the concrete area. So when the first tire touches the grass, this tire will slow down. But this tire won't be knowing that. It will come as it is. All the three other tires will come in the same speed, but this tire will slow down. The impact will be the trolley, instead of going in a straight line like this, it will slowly stop there and will bend and come to the grass like this. The same thing happened in the case of light as well. Light was coming through a rarer medium, it came to a denser medium and the light got bended. Think of this trolley. This trolley is coming in a straight line like this. If we analyze the previous slide, here this line represents the normal. So in this case, this trolley is coming through the normal. So here, both the tires meet the grass at the same time. So the speed of both the tires will get reduced. The speed of this trolley will get reduced, but the trolley will continue moving in the straight line. In this case also, the speed will get reduced, but because of this tire, it will bend slightly towards left side. But in this case, since both the tires are touching the grass at the same time, the speed will reduce, but the direction will not change. It will come through the straight line itself. Which means that when a light comes through the normal, it will go through the normal itself without bending towards any of the sides. But if the ray of light is coming and getting incident here in a slanting position like this, then it will surely bend towards the normal. Now let's see what happens when this trolley comes out of the grass. Here again, when the trolley is coming out of the grass in a slanting position, here this tire enters the concrete area first. So this tire will get more speed, but all the other three tires will move in the same slower speed. So again, since this tire is moving with higher speed, this trolley, instead of moving like this, it will bend towards right side. So here the trolley came like this. We have the normal here Instead of going in straight line like this, it got bended towards the normal. Again, while coming out, the trolley is supposed to move in the straight line, but since this tire entered the concrete area first, it will move away from the normal. That's it. Coming to this trolley, again, this trolley is coming in a straight line, it is coming through the normal. So according to this trolley, when it comes out of the grass, the speed will increase, but both the tires will touch the concrete area at the same time. So speed of both the tires will increase at the same time. So the entire speed of the trolley will change, but still it will move in a straight line like this. Let's see what we have studied once again. We started by asking, why do we see the top part of the pencil and the bottom part of the pencil differently inside water? We discussed that light always travels in a straight line in a single medium. When the medium changes, the speed of the light will change. That's why the light will bend. So bending of light is called refraction when it comes from one medium to the next medium. Refraction is the bending of light when it passes from one medium to another. The bending is caused due to differences in the density between two substances, so that the speed of the light will change and it will bend. Then we discussed about water and air. The light was passing from air to water. Only one thing that we should remember is, whenever light comes from a rarer medium to a denser medium, it will bend towards the normal. Whenever light comes from a denser medium to rarer medium, it will move away from the normal. Think of the father and the child. When it is too much crowded, they will come together. When it is less crowded, they will move far away. Still, if you have doubt about why light is bending, then think of the case of trolley. In the case of trolley, when it comes from the concrete area to the grass, because of this tire, instead of going like this, it is bending towards the side. Now, when it is coming out, instead of going in the same direction, again because of this tire, it will come towards the side. Please keep in your mind that these two lines will be parallel. Now, when the trolley comes in straight line through the normal, the speed will increase or decrease, but still it will move in the same direction. Before winding up, let's try to answer some of the questions. Here, a ray of light is coming from air and it is entering water. How will this ray move? Just keep in your mind that this ray is coming through the normal. So what will happen to the ray when it comes through the water? So what will happen to this ray when it comes and touches the surface of water? Please comment the answer below. Next is, what is the cause of refraction of light? Why refraction takes place? When light travels from water to air, in which direction does the light bend? Will it bend towards the normal or away from the normal? Keep in your mind that the light is traveling from water to air, opposite of what we have seen. So will the light bend towards the normal or away from the normal? Please comment these three answers in the comment section. Thank you.